on 843B, which is 51 to 61 odd. And yesterday we learned about adding matrices. No, that was 2 days ago. Yesterday we learned about multiplying matrices. If I multiply A by B, what do I know about them? Close, you get it backwards. The columns of row A have to have the same number as the rows in matrix B. So for A times B, if I had a 4 by 3, then B has to have 3 columns. 3 by anything could be 7. These have to match, and the resulting matrix is going to be a 4 by 7. So a 4 by 3 times a 3 by 7 is a 4 by 7. Can I calculate B times A? Not unless they're both square and they're the same size. So the only way to do A times B and B times A is if both A and B are square and they have the same order, meaning they're the same size of square. Okay? And we found out that A can usually be inverted. So there is a matrix A, and using matrix multiplication, it's an operation, just like addition, subtraction, multiplication, and division. So it has to have an inverse. So a lot of matrices have an inverse called A inverse. Now, I haven't shown you how to calculate that yet, and there are a couple different ways to do it. But I know that if I take A and I multiply it by A inverse, I get, it's called the identity. Anytime you combine an element with its inverse, you always get the identity. 1 minus 1 is 0. 0 is the additive identity. 4 times 1/4 is 1. 1 is the multiplicative identity. And the matrix identity looks like this. We have 1, 1, 1, and everything else is made up of zeros. Now, there are lots of matrix identities according to size. There's a 1 by 1 identity. It's the matrix that has 1 in it. There's a 2 by 2, a 3 by 3, a 4 by 4, and so on. And you can take any matrix and multiply it by the correct identity, and you get the original matrix. So, yes, in order for a matrix to be invertible, it has to be square. And you know that because A times A inverse is the same as A inverse times A. That's one of the rules of invertibility. So matrix multiplication does not commute. And a lot of people say the commutative property. We're not starting a commune. It's the commutative property. Oh, hey, whoever wrote my poster wrote commutative. How nice of them. It's commutative. It commutes. It travels. I need a new poster. My old poster was right. I don't even remember who did that. So, invertibility is always commutative. Always. Is matrix addition commutative? Is A plus B the same as B plus A? Yeah. But multiplication does not commute unless you're using the identity or inverses. And if you multiply a matrix by its inverse, you get the identity. The only question is, how big is the identity? And it depends on the original, which is why the only way to invert a matrix is if it's square. And just being square is not enough. The rows have to be independent from each other. Essentially, they cannot be parallel lines. So if I had 4, 3, 1, 6, is that invertible? 4x plus 3y, is that the same as 1x plus 6y? No. But if I had 2, 1, or 2, negative 1, and negative 6, 3, is that invertible? Well, let's times this top row by -3. I get -6, 3, -6, 3. This system would have no solutions or infinite solutions, depending on what the augmented piece was. Okay? And essentially what this is saying is, if you want to create a plane using two lines, those two lines have to have different slopes. Okay, so let's say I had this line here, and then I had this line here. Could I move, you guys know what vectors are? Have you seen vectors in physics? Okay, let's talk about it in vectors. That makes a lot more sense. So let's say I have this vector and I have that vector. Could I create this point using those vectors? Yes. All you'd have to do, we could reflect this vector so it points that way, and then we can make it a little bit longer. So I'm going to times this vector by 2 and make it negative so it goes the other direction. And then I'm going to add that vector onto it, and there it is. As long as the two vectors are going in different directions, I can create any point I want in 2 dimensions. Okay? But what if those vectors are traveling in the same direction? So if I have this vector and this vector, can I create that point? No. What if the second vector was going in this direction? It's still parallel, and row operations allows me to multiply, which means I can change the length, or I can inverse the direction, and adding to them together is just going to make them longer. So in this case, if the vectors are going in the same direction, I can only create points that are on that line. So any vectors going in different directions is enough to create any point. And that's what the whole class of linear algebra is about. Is, do you have enough information to fill the 3 by 3 space? Or is some of the information duplicated? So if you have a matrix where row 1 and row 3 by 3 matrix where row 1 and row 2 are the same, but row 3 is different, you really only have 2 unique vectors. Can you fill a 3-dimensional space with 2 vectors? No, you need 3. So if any of the vectors are duplicates or parallel to each other, then you don't have enough information to fill the space. If there's not enough information to fill the space, then the matrix is not invertible. Okay? So if I had this, is that matrix invertible? Well, are any of the rows identical? No, but what if I take row 1 and row 2 and add them together? Then I get row 3. So this is really row 1, row 2, and row 1 plus row 2. Do I have 3 independent vectors? No. I need a row 3 in there somewhere that doesn't rely on something else. Now, if I change this, so let's get rid of that. If I change this to row 1 plus row 3, now am I okay? Yes, because I have a 1 and a 2 and a 3. I'm fine. Right? So not all of the matrices are invertible. They have to be square, and the rows have to be independent from each other. You basically need equations that have different slopes. So how do we find the inverse? Well, there are a couple ways to do it. The one Cynthia Young has us do is, okay, it actually involves less learning than some of the other ways. This isn't the way I did it in college, but it doesn't really matter. It's all the same thing. So 843. Oh, 43, sorry. All right, look at number 52. First of all, is this invertible? Why? It's square. That's the first thing that has to happen. Are the rows independent? So if I draw these vectors, so x, y, the first vector has an x of 3, 1, 2, 3, and a y of 1. So there's the vector. And the second one has an x of 2 and a y and 1. Are those vectors parallel? No. They're not parallel, so we have two independent vectors, which means this is invertible. So we know that A times its inverse equals what? I2. So how do I solve for A inverse? I divide by, well, not I2, I divide by A. How do you divide matrices? You can't. There is no matrix division. So what's the opposite of multiplying by A? And it's multiplying by its inverse. So I can actually multiply by the inverse here. What's A inverse times A? This is I2. And what's I2 times A inverse? A inverse. But if I multiply this by A inverse, then I have to multiply the other by A inverse. That didn't work. A inverse is equal to A inverse times I2, which we already knew, right? So A inverse is equal to A inverse times the identity. Well, that's the definition of the identity. Anything is equal to itself times the identity. So that didn't work. Oh, just for fun. So we have this little trick. And we're going to do reduced row echelon form when we augment this matrix with the identity. So I'm going to augment this with the identity, which is 1, 0, 0, 1, and just make it one big long matrix. Now, if I do reduced row echelon form on this, then the augmented piece is going to turn into the inverse. Okay? So I need a 1 right here. How would you do that? Row 1, well, you could divide by 3, but I don't want to. Why is dividing by 3 a bad idea? You're going to get fractions. So I'm going to do row 1 minus row 2. So 3 minus 2 is 1. 1 minus 1 is 0. 1 minus 0 is 0. 0 minus 1 is negative 1. Oh, sorry. You guys are so picky. 1 minus 0 is 1. Thank you. All right. And then I have 2, 1, 0, 1. Okay. What's my next step? I want this to be 0. I'm going to double R1 and then subtract. So if I double R1, I get 2, 0, 2, negative 2. And then I'm going to do this row minus that row. So my top row doesn't change. 1, 0, 1, negative 1. 2 minus 2 is 0. 1 minus 0, I know this one. It's 1. And 0 minus 2 is negative 2. And 1 minus negative 2 is 3. Now I have the identity here. And the augmented piece is A inverse. Now, I'm just going to double check, just to remind you how to multiply. I take 3, 1, 2, 1. That's A. How do I multiply? What's the easiest way? Put it above and then multiply every row by every column. So 1, negative 2, and 3. And when I'm done, how do I know that I did it right? I should get the identity. So 3 times 1 is 3, minus 2 is 1. That's a good sign. 3 times negative 1 is negative 3, and 3 times 3 is 3, which is 0. That's 2 minus 2 is 0, and negative 2 plus 3 is 1. This is the identity, so the matrix that I created is the inverse. Now, there are other ways to do the inverse, and sadly, the way I learned is more complicated. The way I learned is really easy for 2 by 2s, but 3 by 3s and 4 by 4s is way harder. So let's do a 3 by 3. 56. All right, 56. So I need to put the 3 by 3 identity, 1, 0, 0, 0, 1, 0, 0, 0, 1. What do I need to do to the first row? Nothing. It's exactly what I want it to be. So I'm going to write it down, 1, negative 1, 1, 1, 0, 0. Okay, I want to turn both of these into zeros. So for the second row, I'll take the first one minus the second one. So 1 minus 1 is 0. Negative 1 minus 1 is negative 2. 1 minus 1 is 0. 1 minus 0, I've learned this, it's 1. 0 minus 1 is negative 1, and 0 minus 0 is 0. And then for row 3, what do I want to do? 1 plus 2. Could I do 2 plus 3? Yeah, all I care about is that that first number becomes a 0. It doesn't matter which method I use to do that. So if I add 1 and 3 together, I get 0, negative 1, negative 2. I'm adding 1 and 3. Oh, did I not do it right? Wait, this is a positive 1. Sorry. 1, negative 3, 1, 0, and 1. Okay? Now what should I do? Say that again, Aubrey. And what's the easiest way to put a 1 in the row 2, column 2 spot? No, the easiest way would be switch 2 and 3. Right? So 1, negative 1, 1, 1, 0, 0. That's my first row. I'm going to switch these two. So 0, 1, negative 2, 1, 0, 1. And then if I double row 3, I get 2, negative 4, 2, 0, and 2. And if I add that to row 2 and put it in the spot for row 3, I now have a 0 in the, what would that be, row 3, column 2 spot. So if I add these, those make 0. Those make 0, so 0, 0. That would be negative 4, 3, negative 1, and 2. Get rid of this. Now what? So I want a 0 right here. I also want a 1 right, well, let's not worry about that yet. So how do I get a 0 in the 1, 2 position? Add it to the middle. If I add 1 and 2 together, then I'll get a 0 there. So 1, 0, that would be negative 1, 2, 0, 1. 0, 1, negative 2, 1, 0, 1. So this is 0, 0. What do I want to do to row 3? I've got to divide it by negative 4, so it's not going to be nice. Divide all of these by negative 4. That would be 1, negative 3/4, positive 1/4, and negative 1/2. Okay. And then I would double this row and add it here, and that would get rid of that number. And then I could add these two rows together, and that would get rid of that number. And then the stuff on the right side would be the inverse. We'll look at 53. I'm not going to do it, but let's take a look at it. I know. Okay, 53. You don't like fractions. Okay, let's get rid of them. I can do anything I want as long as I follow the rules. How can I get rid of these fractions? Times the whole top by 3. Should I multiply by 3 after I augment with the identity or before? It doesn't matter. So this would be, if I times those by 3, I would get 1, 6. And how do I get rid of these fractions? Times by 4, 20, and 3. And now augment it. And the first row's done. I already have the 1 here. So how would I get rid of the 20? Times the top by negative 20, and then combine it with the bottom, and that would clear out the 0 in the 2, 1 position. And then I would get a 1 in the next spot, and use that to clear out the 1 above it. And you may end up with fractions. So it's going to be fun. But the process is exactly the same. All right. So 1610. Let's times the top by negative 20. So negative 20, negative 120, negative 20, and 0. That is negative 20 R1. Add that to R2 and replace R2. So those go away. 0. 3 minus 120 is negative 117. 0 minus 20 is negative 20. And 1 minus 1 plus 0 is 1. Now what? So I divide this by negative 117. So 1610, 0, 1, and then it would be 20 over 117, and then negative 1 over 117. Times it by, I would multiply by negative 6, times this row by negative 6, which is 0, negative 6, negative 120 over 117, and 6. Aubrey, where'd you get confused? So if I add these two together, I get 1, 0. What is negative 120 over 117 plus 1? Well, negative 120 over 117 plus 117 over 117 is just negative 3 over 117. If you don't know that, put in your calculator, math fraction, it'll tell you. And then 6 over 117 and 0 is just 6 over 117. And then the bottom row remains the same. So, Maddie, are those the answers in the back? They're simplified? Oh, 117 is divisible by 3. Okay. So, yeah, you're going to pull a 3 out of the top 2. All right. You only have a couple problems to do today. Good luck.